Week 14, Part 1. This will be on two-slit interference. Here's a setup that will be able to show waves here in just a moment. This is a slit, and the waves are going to originate from up here. And if I start them, you'll see them emerging. And then they hit that barrier and leak through the slit just a little bit. It's an opening in the barrier, kind of like a slit if it were an optical system. Don't worry about the weird pattern that's going on up here. That's mainly because of the reflection back off of the barrier. But we want to see what's coming through here. The interesting thing is that it spreads out in all directions, that it doesn't just go straight forward and have a small intensity straight forward and nothing off to the sides, that it sort of turns the corner. The waves turn the corner. That can be understood using Huygens construction. If you think about each part of the wave, let's start this over again. So clear the waves, and then we'll stop it right here. But each point on the wave can be thought of as the source of a little wavelet that's spreading out. Normally those cancel out in all directions except sort of the straightforward direction of the wave. And so the wave doesn't turn corners until you block off part of the wave. And so when this reaches that slit, now this is the only source anymore. And so all of the wavelets from here are all spreading out. And so they kind of recreate this hemispherical wavefront that goes forward. That process is often called diffraction, when waves kind of go around corners like that and spread out. We call that diffraction. Next, what I want to do is look at interference, which is when you have a couple of different sources that are interfering with each other, that we have what we call constructive or destructive interference. So I'm going to change this now, and instead of having one opening, we'll have two openings in the slit. So here is one. Let's clear the waves again. And they're approaching, and they're going to leak through both of these. And you'll see a very interesting process that happens, because as it comes through, they start interfering with each other. And now, in fact, in the straightforward direction down here, you still see the waves like you did before. But there's a funny null region along here where the waves seem to not be present at all, and then they're present again further out here. So there seems to be some cancellation happening right along this particular direction. It's as if the contributions from these two slits are canceling each other out, whereas in the straightforward direction, they must be reinforcing or interfering constructively. Out here again, they seem to interfere constructively. So when you get to a large enough angle, apparently the two waves are back in phase again. And that's going to be the key to understanding what's going on here. Now you might wonder what happens if we change the distance between the slits. So let's make them further apart. Now notice where the nulls are right now, and you'll see a change when I shift to further apart. And now do you see how these nulls are closer together? The whole pattern has been squished together down here. And we see many more features, a lot more null lines now. And the straightforward direction where it's strong is a narrower region. Okay, next we want to try to analyze this a little bit more mathematically with a diagram. So let's take a look at a diagram that shows something rather similar. So here are the waves approaching the slit. In this case, I've got plane waves. We had hemispherical waves before, but it's the same analysis essentially. Plane waves approaching this barrier with two openings in it. The lines here are meant to be the wave crests, and the dotted lines are the troughs between waves. These straight lines with arrows are a different way of representing the traveling waves as sort of rays that just tell you what direction they're propagating. But if you just look at the blue wave fronts that are scattering and spreading out from these openings now, you'll see that in the straightforward direction along this sort of purplish line here, that the wave fronts are on top of each other and the troughs from each opening are on top of each other. So they're right in phase together. And so they would be interfering constructively. On the other hand, at this position, you'll see that each of the heavy lines is crossed by a dotted line. So you've got a wave crest and a wave trough. So they're going to cancel each other out. And it's the same thing here, a wave crest and a wave trough, a wave crest and a wave trough. So that all along here, everything cancels out. That would be one of these, they call it a minimum here. I was calling it a null before, a region of destructive interference. And if you go further, then we're back to constructive interference again. And this pattern keeps on going. Depending on how far apart these are, you can have many of these out here. Down at the bottom are a couple of different ways of representing this. Here would be sort of the intensity. How strong is the signal right here? It's very strong. Here there's almost nothing, so we go back down to 0, and then it comes up again. It's sort of a graph. Here would be if it was light shining on a wall. You might see a bright area and a dark area and a bright area and a dark area, something like that.